Okay, so here's probably to do redox reactions, the most important skill you have to have. You have to be able to figure out what the oxidation states are of the elements in the compound. Okay? If you cannot do that, you don't know if it's going to gain electrons or lose electrons. And you don't know how many electrons it's going to gain or lose. Okay? So literally, if you cannot figure out the oxidation states of the elements in a compound, you cannot do redox reactions. It's like, hey, I want to be on the swim team. Great. Can you swim? No. You're not going to make the team. Okay? Because that's kind of a core requirement to be on the swim team, is that you can swim. Call me radical. I think floating might be just as important. Can you float? No. Really. Swim team might not be your thing. So what we're going to do is we're going to go through and make sure everybody's cool with this process. So notice on these first three, you got sodium sulfate, KMnO4, calcium nitrate. So you always start with oxygen, okay? Because oxygen always has an oxidation state of what? 2 minus. Now, all of these overall have no charge because there's nothing written up here. None of these have like an overall charge. So what do you want the sum of all the oxidation states to equal? 0. We're not making it add up to pi or the square root of -1 or anything weird like that. We're just going to make it add up to equal to 0. So start with your oxygen. You have 4 oxygens that are -2, which gets you a total of what? -8. Okay, so I've got that one. Got my -8. Cool, I got that one. Now, go to sodium. Sodium's on the far left side. It's an alkali metal. How many valence chihuahuas does sodium have? Only has 1. So sodium, unless it's really, really weird, is always going to be +1 because it only has that 1 valence electron. Okay? So what do you think the oxidation state of sodium is going to be? +1, but there's 2 of them. So that gets you to +2, right? So that leaves sulfur, then is going to have a charge of +6. Now, this works in terms of oxidation numbers, but realistically, it works. It's an accounting method, but I guarantee you, sulfur has 6 valence electrons. It's not going to lose all 6 electrons to do this. Will it basically maybe share them on a timeshare, like a condo in Florida? Maybe, but it works as an accounting method, okay? So we'll say it's going to be +6, but you might also see sulfur have a different oxidation state. But it's going to make the math work out. Okay. So then, on the next one, you want the nitrogen in calcium nitrate. So, what I would recommend is that let's just look at the nitrate itself. Okay? What's the overall oxidation number of the entire nitrate molecule? -1. So this whole thing is -1. Okay? You've got 3 oxygens, each at, so total of, so the nitrogen is going to be +5. Okay? And again, it works. Nitrogen is not going to lose all 5 of its outer shell electrons, but it works. Now, in contrast to that, let's say you had NO2 1-. We just talked about that. Spent a lot of time talking about nitrite. So nitrate is NO3, nitrite is NO2. Remember, 8s always have more oxygens than ites. Sulfate is SO4, sulfite is SO3. Nitrate is NO3, nitrite is NO2. So 8s always have more oxygens than ites. Well, what would the nitrogen be here? Well, I got 2 at -2, so that gets me. So the nitrogen here is going to be +3. Okay. Now, let's talk about potassium permanganate. Potassium permanganate is one that we will use a lot. Okay, so let's make sure everybody's cool with this potassium permanganate. It's one of the most common chemicals used in redox reactions. So I want to make sure everybody's cool with it. Now, you want to figure out, in this case, what's the manganese going to be. Manganese is unique because if there's ever an element that has a whole slew of oxidation states, it's manganese. Manganese can go all the way from 7+ down to 2+, okay, depending on what you bonded with. So manganese is literally has the most possible oxidation state than about any other element. So start with this. You got 4 oxygens, that's going to be what? -8. Potassium is going to be what? +1. So therefore, the manganese in this situation is going to be +7. Okay? So, try all of those on number 1 right quick, and then I'll go over the answers with you. These are just lesson notes. Okay, so that's what you should have gotten on number 1. For those oxidation states. So that's again, if you cannot do that, you cannot do anything else. Now, on those other ones, 2, 3, there's some questions there. Those are practice. Okay, I will, if you want to come up and practice those, I've got the answer key up here. But if you've got this is not an assignment, but this is what you've got to be able to do in terms of redox reaction. Okay. Now, okay. So the lecture notes that I gave you, here's what we're leading up to. And this is balancing reactions using half reactions. So what I've given you is the step-by-step process on how this works. I'm going to work one simple example. So this is like one of the things you're going to do in the lab tomorrow. We're going to take potassium permanganate, which is going, all we're going to worry about is the permanganate ion, MnO4 minus. And we're going to put that in the presence of Fe2+. And we're going to get Fe3+ and Mn2+. Okay? So this is what's known as the skeleton reaction. This is not balanced by any way, shape, or form. All that's saying is that we're going to take permanganate we're going to put it in the presence of Fe2 plus ions. We're going to end up with Fe3 plus and Mn2 plus. So there's a couple of things that are important. Number one, this method that I'm going to show you only works in an acidic environment. So tomorrow when you all mix this together, one of the things you're going to add is sulfuric acid, because you need a whole bunch of hydronium ions to make this happen. So the reason we call it the half reaction method is that you're going to do the oxidation and then you're going to do the reduction. You do them as two separate half reactions. That's why it's called the half reaction method. So if you do the reduction part of this first, which is going to be the more complicated one. So you have the MnO4, and that's going to turn into Mn2 plus. Okay? Now, here's the story. When you get done, everything has to balance on charge and number of particles. So this is why you have to be able to figure out the oxidation state of manganese. Oh, manganese here is 7 plus. It's going to end up at 2 plus. So what did it do? Did it gain chihuahuas or lose chihuahuas? How many? So it gained 5 chihuahuas. Okay? Now we're not balanced yet because I've got some oxygens. How am I going to balance those? Water to the rescue. So you use water, if you need to balance out the oxygen. So I've got 4 waters over here, so I'm going to put 4 waters over there, so that way I can get my 4 oxygens. Okay, that's the reason I chose 4 waters, is because I've got 4 oxygens here, and the only way I can get 4 oxygens over there is to have 4 water molecules. Okay, now we're not balanced, because now I've got 8 hydrogens. So what do I need on the other side? 8 hydrogens. But this is going to be in an acidic environment. So instead of adding hydrogen gas, I'm going to add 8H plus. Now, here's the story. At this point, you can always check that this is balanced when you get done. If I add together all the charges over here, I've got -5 because I have 5 chihuahuas. I've got a -1 here, so I'll look at -6. And then I'm going to add 8 positive charges to it. So the sum total of everything over here is +2. The only thing that has any charge over here is the manganese. That's also +2. So it's balanced with charge. I've got 8 hydrogens. I've got 8 hydrogens. I've got 4 oxygens. I've got 4 oxygens. Everything's balanced out. Okay, so that's the oxidation side of it. Now, the iron is easy, because that's just going from Fe2 plus into Fe3 plus. So what did it do? Gained or lost a chihuahua? Lost one. Oh, so we're going to put 1 electron over here. I don't have to worry about oxygens. I don't have to worry about hydrogens. That's it. But electrons lost have to equal electrons gained. So if there was a 5 here, that this thing is going to gain 5 electrons, how many electrons do you think the iron has to give up? Maybe 5. All right? So I'm going to go through here and I'm going to multiply everything here by 5. Now, here's my 2 half reactions. Now I'm going to add these together. Oh, when you add these together, your electrons should cancel out. You should have the same number of electrons on both sides so they cancel out. So when you add these together, I get MnO4, 1 minus, plus 8 hydronium ions, plus 5 Fe2 plus. That gives me 5 Fe3 plus Mn2 plus 4 halogens. Okay? This is my overall reaction. What should my overall reaction balance on? Charge and number of particles. Okay, I'm done. So, okay, 2 half reactions to balance. That's all you got. There's not even a backside to it. And if you're not sure of the steps, read through those steps. That's your only homework. That's it. Go ahead.
Also, when I get back tonight, can I ask some questions about Chem? Yeah.
Yeah.